Hello students, welcome to Taylor series expansion for function of 1 and 2 variable problems. Let's get started. The question is here may ask like this. It's a function of single variable problem. If you observe here, obtain the power series expansion of sine 2x in powers of x minus pi by 4. Or he may ask like this, find the Taylor series expansion of sine 2x about x minus pi by 4 or around x minus pi by 4. May ask like this. It clearly seems the given function is a function of single variable. Okay, but the thing is here in terms of x minus pi by 4. If it is only in terms of x, now, so in that case we need to apply Maclaurin series. So here he is not mentioning the Taylor series or Maclaurin series. How to distinguish Taylor and Maclaurin's means it's in Taylor case x minus some a is any real number, maybe like x minus 1 or x minus 2, something like x minus pi by 4, x minus pi by 3, such a way. Okay, so when it comes to Maclaurin series case, so that case how to identify means only in powers of x. That is the idea. Otherwise, so he may ask directly. So in directly case, so find the Taylor series, he will ask in terms of x minus some number, or Maclaurin series in powers of x directly, that is. Now let's start the solution. I can suppose the given function is, let f of x equal to, it's a function of single variable sine 2x. You have given, we need to express in powers of x minus pi by 4. So which means you can compare with x minus a. Because I'm going to write now rule, since here a equal to pi by 4, I'm going to write the rule Taylor series Taylor series of f of x, Taylor's series of f of x about x equal to a is defined like this. F of x equals to f of a plus x minus a power 1 by 1 factorial times f dash of a plus x minus a whole square divided by 2 factorial times double dash of a plus sine x minus a whole power 3 by 3 factorial times triple dash of a. Again subsequent terms we can, okay, we could write here the fourth derivative is x minus a power whole power 4 by 4 factorial times f fourth derivative of a, so on. Let's mark this is equation number 1. Now since we know that a equal to pi by f of x equal to f of pi by 4 plus x minus pi by 4 power 1 by 1 factorial times f dash of pi by 4 plus x minus pi by 4 whole square divided by 2 factorial times f double dash of pi by 4 plus again so on. I'm not writing here. So rest of the subsequent terms supposing, so triple dash of pi by 4 fourth derivative of pi by 4 plus again so on. Let's mark this is equation number 2. Now the requirements as per the equation 2 are, so we need to find f of pi by 4, f dash of pi by 4, double dash of pi by 4, triple dash, if required fourth derivative also we will find out. Let's go for next page. Here we need to find function values and derivative values. Okay, so let's, since we have, since f of x equal to, since f of x equal to sine of angle 2x, so which means f of pi by 4 we require. F of pi by 4 means sine of angle 2 times pi by 4, which means sine of angle pi by 2, sine 90, that's one. Okay, now find f dash of x. Derivative of sine 2x is cosine 2x. Again this 2x derivative is 2. I'm going to write here 2 times cosine 2x. This is 2 times cosine 2x. F dash of pi by 4. The next step, sine, it is cosine, 2 times cosine, 2 times cosine, 2 times pi by 4. Substitution of x equal to pi by 4. Okay, so in place of x equal in place of x, which means 2 times cosine pi by 2. Cosine 90 is 0. 2 times 0 is 0. Now double dash of x, double dash of x. So here cosine 2x derivative minus sine 2x. Again sine 2x derivative 2. So already we have here 2 is there. So minus sine 2x again, which is multiplied by 2, which gives minus 4 times sine 2x. Sine 2x. Now find out here f double dash of pi by 4. Clearly it seems 0. Minus 4 times sine of 2 times angle pi by 4. Now here this will be equal to minus 4 times sine 90. Sine 90 is, it is 1. So equal to minus 4. Sorry, it's not 0 value, it's a non-zero value, minus 4. Okay, again I want to find here f triple dash of x. Triple dash of x means sine 2x derivative cosine 2x multiplied by 2, which means already we have outside coefficient is minus 4, which means minus 4 times 2 is minus 8 cosine of angle 2x. Now f triple dash of pi by 4, this is equal to, clearly this will be 0. Cosine terms becoming 0 because of angle 2x, or pi by 2 you can say here, pi by 4. So minus 8 times you will get cosine 90 because 2 ones 2 2's, pi by 2, cosine pi by 2 is 0. So finally the answer is 0. Cosine terms become 0. Now fourth derivative also I will calculate. This will give you cosine 2x derivative minus sine 2x. Already minus is there. That minus, this minus, both will be multiplied. So you will get here, okay, 16, because cosine 2x derivative minus sine 2x multiply by, again by chain rule, 2x derivative 2. So finally 16 sine 2x, positive 16. So f fourth derivative of pi by 4, we will get here 16 times sine of 2 times pi by 4, which gives 16, because 16 into sine pi by 2, that will be 1. So I will put here so on symbol. Now we need to substitute. So this result, f of pi by 4, f dash of pi by 4, double dash, triple dash, again for the derivative values in equation 2. In equation 2. Okay. So the next step will be, therefore we can say, therefore equation 2. So which implies we have LHS. LHS is f of x, RHS is f of a. F of a from this page, it's 1. F of a value 1, plus I'll put here x minus a. A means pi by 4 power 1 by 1 factorial times f dash of a. F dash of a is 0. So which means 0 here. Plus I'll be writing x minus pi by 4 whole square divided by 2 factorial times f dash of a, f double dash of a, which means this is f double dash of a is minus 4. Now substituting minus 4. Now again plus I am writing here in formula, I have not written, but I am writing here x minus 4 power 3 by 3 factorial times triple dash of a 0. If you look previous page, so it's 0 triple dash. Fourth derivative, it's a non-zero value, plus what I will do, plus x minus, this is also not written in formula, so power 4 divided by 4 factorial times 16 plus so on. Let us say here positive sign I kept it here. So is it positive, or we can guess positive or negative next term? That will be 0. Okay, anyhow the next term will be a negative term. You would expect the next term will be negative. Can try. Here what I will do, negative sign I will put negative sign, that is this minus so on. Okay, so this the next step, simplification, LHS sine 2x which is equals to simplification 1. Again I have here second term total is 0, third term. So third term is we have here 2 factorial, again here 4, which means 2 factorial value 2, again 2 2s are 4, which so finally you will get minus 2 times x minus pi by 4 whole power 2, that's enough, plus sign. Again we have third term here, third term is 0 because of 0 times x minus pi by 4 whole cube is 0. Fourth term is a non-zero. Fourth term is a non-zero means 4 factorial is 16. So I'll be writing here 16 divided by 4 factorial. I'm calculating 16 by 24. 4 3s are 12, 12 2s are 24. So 4 4s are 4 6s are. So again 2 2s are 2 3s are, which means 2 by 3 times x minus pi by 4 whole to the power of 4 minus so on, minus 1, which is the required Taylor series in powers of x minus pi by 4 for the given function f of x equal to sine 2x. Let's take the new problem. So this is question number 2. Here it's a function of two variables. Obtain the power series expansion of e to the power of xy in powers of x minus 1 and y minus 1. He is not asking here also directly, so Taylor series. So we need to look x minus some non-zero number, again here y minus some non-zero. This is the case for we need to apply Taylor series for function of two variables. Here because of x and y we need to apply two variables. Or directly may ask like this, find the Taylor series expansion of e to the power of xy in the neighborhood of 1 comma 1 or about the point, okay, 1 comma 1 or around the point. So maybe ask like 1 comma 1 in this case. So first let's start the solution. The solution is, I can suppose here, let the given function f of x comma y, I will say now function of two variables, notation is f of xy, which is equals to e to the power of xy. The point is given as, so 1 comma 1, so you can compare or you can say, so x minus 1 and y minus 1 clearly given. So here x minus 1 and y minus 1. So let us suppose this is A and this is B. Okay, first I'll write the rule. Since Taylor's series of f of x comma y about a comma b is defined as like this, f of x comma y, which is equals to, I'll be writing first term f of a comma b plus 1 by 1 factorial times x minus a times fx, means partial derivative of x with the partial derivative of f with respect to x at a comma b plus x minus b, sorry, y minus b, y minus b times fy, which means partial derivative of f with respect to y at a comma b, close the bracket, plus 1 by 2 factorial, which is multiplied with, so here x minus a whole square times, these are first order partial derivatives. Now I am writing here second order partial derivatives in, okay, in this term. So f double x means dou square f by dou x square at the point a comma b plus, now the second term here x minus 2 times x minus a, which is multiplied by y minus v, again mixed partial derivative at same point a comma b, plus the last term here y minus b whole to the power of 2 f double y at a comma b, close the bracket, and after that plus so on. Again we can write here third order also, fourth order also, depending upon given problem here. So it is enough, so up to second order terms, so we can find second order derivatives in okay using given function. Let us mark this is equation number 1. Now we need to plug in a comma b. A is 1, b is 1. Next page, since we have a comma b equal to 1 comma 1 point is given, so a equal to 1, b equal to 1. Now the above rule reduces f of x comma y equal to f of a comma b, which means f of 1 comma 1 plus 1 by 1 factorial, which is multiplied by x minus 1 times fx at 1 comma 1, again plus y minus 1 because b also 1, fy at 1 comma 1, close the bracket, plus sign 1 by 2 factorial times here x minus 1 whole square f double x at 1 comma 1, again second term plus 1 by 2 factorial, sorry, here second term is 2 times x minus 1 again, which is multiplied by y minus 1, again mixed partial derivative at same point 1 comma 1, plus sign the last term is y minus 1 whole square f double y at 1 comma 1, close the bracket, again plus so on. Let's suppose this is equation number 2. Now the requirement as per the equation number 2 or namely we need to find first order partial derivatives fx fy and second order partial derivatives, okay, so f double x, again we have xy, again double y. So the simple way, first find fx and subsequent derivative, again immediately find right after fx find f double x, find fy right after fy find f double y, later on we can find f double and fxy finally. So the total number of derivatives here 1 2 3 4 5 derivatives requires. This value we can, okay, directly obtain from the given function. So let's start finding the results. Okay, since we can say, since we have f of x comma y, the given function is e to the power of xy, so find out f of 1 comma 1. So without differentiating, just substitution of x and y, e to the power of 1 time 1 is e power 1, e power 1 is e. After that I need differentiation, partial derivative, this one I want to find first. How to find fx? Fx means differentiating f with respect to x partially by keeping y constant. You know the partial derivative rules. Here differentiate e power xy with respect to x by keeping y constant, that gives fx. So fx equal to e to the power of xy, which is multiplied with again xy derivative with respect to x by keeping y constant. So you will get only here only y because x derivative 1. So finally, so y times e power xy is fx value. Again I can go for f double x, f double x. So which means what? Differentiate this quantity with respect to x. So here there are, this is a exponential function, this is a algebraic, both are multiplied, otherwise I will be simplified form I am writing. This is equal to y times e power xy, you can say. Now here y is anyhow constant, only differentiate exponential term. So in that case you will get here with respect to x means y same e power xy derivative e power xy, again xy derivative y. So finally y square times e power xy, fx f double x completed. Now fx value at 1 comma 1 we will find with the help of this function. So this will give you 1 time e power, again 1 time 1, which means e only answer. After that here, now again f double x at the same point 1 comma 1. Substitute or plug in the values 1 comma 1. 1 square is 1 square time e power 1 time 1, which gives e only. After that I need here, this is finish, again we double x finish, again this one also finish, three results finish as of now. Now we need to find fy, this one I want to find fy. So fy means I'll be writing here fy. What does it mean? Differentiating f of xy, this one, with respect to y by keeping x constant. Criteria is by keeping x constant. Fy equal to, so e power xy, again xy derivative with respect to y. Here x into y case with respect to y means y derivative 1, x left, x into 1, x, finally x. So this gives x times e power xy. Now find out immediately fy at 1 comma 1 is how much. This is also giving 1 time e power 1 multiplied by 1 equal to e. Now after that I want f double y. F double y means this function differentiate with respect to y. With respect to y. Anyhow x is constant, that you can keep in mind. X times only differentiate this part. So when you differentiate e power xy derivative e power xy multiplied by again xy derivative is here y. So again xy derivative is y. So finally you will get here y. So which gives xy here multiplied with again xy derivative. Okay, you will get here, sorry, you will get here xy derivative here left with x because y derivative is y. Y derivative is with respect to y is 1. So finally you will get x square times e power xy. Now afterwards substitution of the point f double y at 1 comma 1 which gives again 1 square times e power 1 dot 1 equal to e. We left with only mixed partial derivative lastly. So I'll take new page. Since otherwise fxy which is equals to, so this could be writing like this, dou square f by dou y times dou x, or else we can say here dou by dou y of dou f by dou x. So as we know the symbols, this is same as dou by dou y of dou f by dou x means this is fx. The fx result is y times e power xy. I have to be substitute here y times e power xy. Now for this function differentiate with respect to y. So in this case be careful. The reason is here y is there, again in e power also we have y is there, two places y. Apply the uv rule, product rule. So the product rule I am writing over here. The product rule is, since we have this rule d by dx of, so u times v equal to u times v dash plus u dash times v, or v times u dash you can say anyway. So let us, this algebraic function is u and this exponential is v, suppose like this. So y times, now derivative of e power xy partially with respect to y. So which means e power xy derivative e power xy multiplied with respect to y means x left here. Okay, plus sign. Now u dash y derivative with respect to y 1, so into v means e power xy, which gives x times y e power xy. Okay, plus e to the power of xy. So this is my only partial derivative, mixed partial derivative of xy. Now I want therefore fxy at point 1 comma 1 I am calculating here. So all the places you can substitute 1 time 1, which means wherever x is there, x equal to 1 y equal to 1, 1 dot 1 plus e power 1 dot 1, which gives e plus e equal to 2 times e. Only this mixed partial derivative result is 2 times e. Rest of the terms are coming over here as of now, so only e. Okay, all these results we need to substitute in equation number 2. Therefore equation 2 implies, equation 2 LHS is f of x comma y. RHS is, so we have f of 1 comma 1 that is e plus 1 by 1 factorial times x minus 1 multiplied with fxy. Fxy also I think all the terms are e, so I'll be going back. All the results are, so we have e, fx is e, sorry f is e, fx is e, double x also e, y also e, again double y is e. Only mixed partial derivative is 2 times e. So I will be substituting in corresponding places. This is e plus y minus 1 times again e, close the bracket, plus 1 by 2 factorial times the first term here x minus 1 whole to the power of 2 multiplied by e, again plus 2 times I am writing over here 2 times x minus 1 multiplied with y minus 1, mixed partial derivative here 2 times e, this is careful, plus the last term is y minus 1 whole square again multiplied by e, close the bracket, plus so on. This is same as, so finally we can simplify last step. Fxy means e power xy, so it is equal to, we can say e common from the, okay, infinite series. So otherwise, so we can say here e is common here. So if I take e is common, the series will become 1 plus 1 by 1 factorial is, okay, that's 1. So finally we can say x minus 1 plus y minus 1 again here plus sign. Okay, I'll close the bracket here. E is common means, so I'll be writing here under brackets plus sign 1 by 2 factorial which is multiplied with Again here this is same, x minus 1 whole square plus this will be 4 times x minus 1 multiplied with y minus 1, because 2 times 2 here, this will give 4 plus sign y minus 1 whole square, close the bracket. Again I can say here plus so on. So better so on continuation. I'll put here outside here one more square bracket because e is common. So this is the required Maclaurin's Taylor series in powers of x minus 1 and y minus 1. Thank you, students. Thanks for watching.